Hi everyone, my name is Colin. This is Lyle, Adewole, and John, and together we're JDLC. We really appreciate you sticking it out today and learning more about our product, Assist3D, which is the open source 3D printing of modular assistive technology. Our story begins at the HMS School, which is a school for children with cerebral palsy in West Philadelphia. Cerebral palsy is a movement disorder, affecting children to different degrees, and is caused by brain damage before the age of 3. Cerebral palsy not only affects the children themselves, but also their teachers, their parents, and their caretakers. According to the CDC, over 500,000 children and adults are affected, and it costs $94,000 in direct medical costs just to support one of these children over the course of their lifetime. And that includes hospital visits, long-term care, and also assistive technology. And we aim to decrease the amount for assistive technology. This is Greg and Steven. They're just two of many of the children at the HMS school who have cerebral palsy. It's difficult for them just to complete daily tasks and simply just be kids. Their way to interact with the world around them is by using these ability switches, as you can see by Steven right here in green. An ability switch is a button that Greg and Steven can press so that they can play their favorite video games, they can move their wheelchair, and they can even talk and communicate using these screen interfaces like you see behind me. However, the problem with these current ability switches is that, one, they're very expensive to both purchase and repair. For example, the leading competitor, AbleNet, their button can cost up to $200 for just one of these ability switches. And two, they were never designed to be custom to the needs of each child. When I described earlier cerebral palsy, some children might be able to move their arm and be lucky enough to press one of these buttons, but a good portion of them just can't. They might have to move their leg a little bit or maybe move their head to press one of these buttons. So in crafting our solution, we wanted to make a product that was affordable, customizable, and simple. And now Lyle will talk about a particular product.
Thank you, Colin. Thank you. So we use these three objectives to craft a solution that is twofold. The first part of our solution consists of the process of designing and manufacturing our product, which in this case is a 3D printed button. It consists of an interlocking cap and dome and allows our clients to interact more easily with their surroundings. The second half of our solution pertains to the means of distributing our product in the form of a website. This website allows our clients and their guardians to gain easy and direct access to our resources. It also provides a streamlined process for them to choose a button that best suits their need. Now let's take a closer look at this need. On the left, you see our client, and on the right, you see their environment. We have chosen to bridge this gap with our ability switch. But where does it begin? Our process begins with our 3D printer. This 3D printer can be used to create modular components that can be mixed and matched like Legos to create our final product. This final product will be customizable in the sense that the child may be able to use it with their leg, their arm, or even their head. Even though we have this high-level customizability, we have been able to keep the cost of our product extremely low. Competitors like AbleNet charge around $60 just for the basic module. Ours, on the other hand, costs only $8.66. This is our solution. As you can see here, we have many of our components, and I've even hooked up one to an LED light and a buzzer just to show functionality. This something would be used, like Colin had mentioned, to move the wheelchair or even interact using their interactive systems. Now, we've also been able to expand on this, and we've developed wireless capabilities. In fact, we've been using it this entire time. Now that I've given you guys a general overview of our process and our product, I'd like to pass it off to Dio to talk about the more technical details.
Thank you, Lyle. So when designing this button, we want to make sure that when you print a button, you get the same model every time. We have a 1% error margin on 3 of the geometric features that are available throughout all of our buttons. We also want to make sure it's safe so that it doesn't fracture when a kid's using it. So we made sure that our button have to withstand at least 1,000 newtons of force or more before fracture. To mitigate the financial burden on the consumer, we made sure that our total system had to cost $50 at a maximum. We also wanted to make sure that all the components needed to build the button were available from a list of pre-selected vendors. We use the system usability scale, which is just an industry standard that companies use to judge how intuitive it is to use a system. And we want to get a 68 or above on this test, which is, again, the industry standard. We also want to make sure that our button was customizable. Because kids will use different parts of their bodies to activate it, we wanted to make sure that they would be able to use their leg, their head, or their arm. We also ensured that we had 3 different sizes, small, medium, or large. So this is just a diagram of the button. The cap and base are 3D printed. The springs allow you to determine how much force is needed to actually activate the button. And the push buttons just allow it to be connected to any sort of electrical device. So we also have a website, just a distribution system, and I'm going to take you through a live demo playing the role of a client who would want to purchase one of our buttons. So as you can see here, we just have a brief summary of the technology, a link to make your own device, as well as 3 of the main design objectives. Click here to make your own, and let's say I want to use my foot and select a large button. From here, I click Submit, and I have 2 options. If I choose to order online, then that will send the design files to a third party called Shapeways, which will print the button and send it back to you. If you choose to make it yourself, assuming you have a 3D printer at your disposal, then there are 3 easy steps: printing, ordering, and assembling the button. For each step, we have step-by-step instructions, a list of links of all the parts you'll need, and finally, an assembly tutorial video, which will tell you exactly how to assemble the button. So again, it's Assist3D.org. And just to reiterate, we've created a system where you can manufacture something with a 3D printer and a distribution system through the website. And we've used it to address a medical need and create an assistive device for children with cerebral palsy. Now John's going to talk you through how we evaluated the progress of our project over the year.
Thanks, Lyle. So in order to see whether or not we could satisfy our internally set criteria, we had to develop evaluation methods. For repeatability, we used caliper measurements of the same model of buttons. For safety, we use the Instron machine and the MSc and BE labs to see the maximum force that the buttons can withstand. For affordability, we took an itemized list of all the components necessary to produce one single button, and we simply summed the cost. For simplicity, again, like Lyle mentioned, we used the industry standard, which was the SUS scale, and we obtained 23 respondents to try and hit the target of 68 score. For customizability and availability, because there was no industry standard, we had to consult our project advisor. And following his advice, we came up with 2 additional evaluation methods. For availability, we took the itemized list and looked at which vendors these parts could be purchased from, and made sure they were from the pre-approved list. And for customizability, we settled on a post-manufacturing inspection to make sure that we had the correct number of configurations and the correct number of parameters. So going into more detail, for repeatability, we looked at 2 things. One is percent error, and one is precision. Percent error is due to printer calibration, so what we really want to focus on is precision. And we see that our system has remarkable precision, which means we're able to print the same button repeatedly and time after time, which is awesome. Next, we have the safety. And we see that our button was able to outperform the industry standard, which is the big red button from AbleNet. And we were able to withstand almost twice as much force. For affordability and availability, we took an itemized list. And as Lyle mentioned earlier, it only sums up to $8.66. And in addition to that, all of the parts could be purchased from our pre-approved list of vendors. For simplicity, behind me is a sample survey of some of the questions that we used for the SUS scale. And from the 23 respondents, we were able to achieve a SUS score of 79.7, which means that our system is simple and intuitive to use. Finally, for customizability, we were able to come up with 3 configurations for 2 parameters. And the 2 parameters that we chose were the body part and the size of the button. So comparing what we promised versus what we delivered, we're happy to report that we were able to meet and exceed all of our expectations. That's why we're really happy and proud to be presenting our product in front of you today. So now that we've seen that we were able to meet our internally developed criteria, we wanted to see what the caretakers thought. So Dawn, who's the director of assistive technologies at the HMS school, said she really liked the button, and she really liked the fact that it was easy to repair. And Brad, who's the music therapist at the HMS school, said he also really liked the button, but he would like to see us implement wireless capability. And lo and behold, in the past 2 weeks alone, we were able to develop this. And now that we see that the caretakers were able to give us such positive feedback, we wanted to see what the kids thought. And as you can see in the pictures behind me, our button is already making a positive impact in the kids' lives at the HMS school. So, looking forward, had we had more time, we would have liked to partner with Shapeways to direct more traffic to our site and gain even more visibility. We'd also like to develop more parameters and more configurations to really drive home the point of customizability. And finally, we wanted to develop an assembly workstation so that the assembly process can be made even simpler. And we have to keep in mind that This system is not only useful for kids with cerebral palsy, but it can also be applied to other populations. For example, patients with traumatic brain injury, with spinal cord damage, with weakness and paralysis, they could also use our system and our assistive technology. And our manufacturing and distribution system could be used to produce other devices as well, such as hearing aids. And ultimately with this, we hope to improve the lives of everyone, including the kids at the HMS school. We'd like to take this time to thank everyone who has helped us out along the process. And again, if you want to visit our website, it's assist3d.org. Thank you very much, and we would like to open up the floor for questions.
I think very interesting that you allow people to download a file and print this to their own 3D printer. And I assume that's what you do is send them a file. So I'm curious how you deal with digital rights management. What stop people from taking that file and selling it without your knowledge?
So it's something that we did consider, and it's something that we wanted to make our designs open source. So it's obviously in the open source community, you can pull down things and start printing them off. And it's something that we wanted to keep a community basis. So we're actually in discussion with the Bogen design group about how we want to distribute this, and through his website and through his distribution stuff, we'll see how we can make this an open source project that everyone can use.
I'm a little hazy on why this is so costly, in terms of competition. What are the parts in this product?
Yes. So if we can move to the appendix. So it's the injection molding. So next one. Okay. Right here. So the reason they're so expensive, it's actually not too difficult to produce these. They can cost like $18,000 just to get a single injection mold. And in order to cut costs and cover this, they have different versions, right? Because they're not meant to be customizable. They have to have separate molds, which cost a lot of money. So then they pass on that cost to the consumer, which makes it like $60 a pop. And sometimes they have other things like these wireless components that they add that are non-standard, which can drive up the prices like to $200.
What's the markup that Shapeways would add for the size of part?
Yeah, so Shapeways, basically you just ship the part and they tell you exactly how much it would cost to print. So it would be a little bit above what it costs with your own plastic, with your own ABS plastic and your own printer, but they would give you a direct quote. And we actually calculated it, and it's under the $8.66 that we already incorporated in our cost. So ultimately, with all the parts and with assembly, it will cost them under $8.66.